So hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 146 and in this video we continue with our repetition of keywords, and of course we don't repeat only, we also extend our knowledge a little bit. And like all time I will use this site here, cpp-reference.com, where because this is a simplified version of the official documentation, and our goal is to understand the C++ official documentation so that you can understand all the keywords in future without asking anyone, because then you understand the official documentation and read yourself what the meaning is, where you can use it, and so on. With that said, we are almost ready. Then here, I hope you know how I do this kind of stuff. I just read here one question, for example is 48, then you can stop the video and try it on your own. And you should it, because it is a repetition and you test yourself a little bit, and then you can play again the video and check it with my answer. And my answers here are anyway not absolute perfect and correct. The reason for that is I can't answer here all the theoretical part here. I will just answer here a short version, which is a little bit points in the direction, and later I will refer just to this site here where the answer is, where you can find the answer actually and read all the details, because that's the problem. I can't answer this question most time, because that will take just too long, waste of time, not possible. But you understand what I mean in a moment, or when you watch my other videos, you know how I'm answering this kind of questions. So with that said, we can start. All right, we are here in 48, and it says here, which number can you write min max, which means min number and max number, to the type int? And here important, which is 32-bit long. So which number is that? And here I missed some words. For example, I mean here decimal number, because there are other kind of numbers too, or let's say presentation of numbers. And we are using in general decimal numbers, but that's not all time true, because there are also binary numbers, octal numbers, hexa numbers, but let's say in decimal numbers, right? You can write, let's write here in decimal numbers, min max. Let's do this one too, so you know now that I mean in decimal numbers. So this one, and the second question is also very similar, absolute the same actually, only that I changed here this bits here. Here you should write it for 32-bit. Here for 12 bits. Try it, and of course I will not pause the video, I will just go on. After you finished it, just start the video and you'll see my explanation. First of all, I answer it now. So first of all, 32-bit, I don't know the number. It is a big number, but I know approximately the number, which is around -2 billion plus 2 billion for unsigned, and signed. Other way around. For signed and unsigned would be from 0 to 4 billion anything. And this kind of numbers you don't need to know actually. If you know it, very nice, because then you know what you can put in these numbers later. That's actually, if you know the little ones is good. The big ones is not so important, depends on your program. And it's not important that you know exactly the number. And why that? Because I will just watch this kind of numbers. I have no clue. And how we make this? We go to the site. I go here to fundamental types. We have talked about this table here, which you see here in a moment here already, right? You know this table. And this table has here integer. So I'm asking for integer, and I'm asking for 32-bit, and I'm asking for min and max. So, and this table has all. First of all, here's integer. Here we have a range of integer in bytes. It says size in bits. So we have here 60-bit, 32-bit, 64-bit. Okay, I need this 32-bit. And then I have the format here, unsigned and signed. So I have really answered both questions here. Both answers here. And the reason for that is because they are not the same numbers, depends on the format. So, and here I just copy it. In my case, it's here and here. I copy this one and I finished. I don't know the number exactly. You can see, I know, here you saw, I know it's here minus 2 billion and 2 billion I said. That's so my approximately said, that's I know, and all other little things here I don't know. And the same goes here too, I know. The positive is just this negative added to the positive one, so 4 billion, 0 to 4 billion. So I hope you was better than me. If not, no problem. Like I said, we are watching these numbers. We don't need calculate this kind of numbers. I mean, you don't need to memorize this kind of numbers. Not very important in programming, but you have to know these numbers and watch these numbers when you really work with big numbers. For example, if you have an integer here, let's go here. And by the way, here, this new system here, all time I scrolled down to main or clicked here main and then scrolled back. I forgot that we have here all this bookmark system, which means I can set here a bookmark and then I can jump to the places where I want. Now I'm very fast at main and very fast back where I was. That's good. Okay, let's here make the example with the int. Of course, when I write here int big number, for example, and then you have to know that this number here, which I wrote now, will not present it here. This one, this number will not work. And let's test this out fast as they did. See out. Oops. And we have my big number here. And let's see what happens here when I print this out, this big number. And you see here a strange minus anything. And the reason for that is, let's copy this one here so that we can see it better. And the output here is this one. And the reason for that you see this strange number is exactly this one here. It is integer. I have 32 bits. And I can only put in this range here. One more thing. How I can see which number I can put in. Because we have a range. We have here 60 bits, 32 bits, and 64 bits. Which one is my system? How you can test this? And there was this keyword size of, right? Perhaps you know it. Perhaps not. No worry. And you can write here, for example, size of, in my case, int. So this one we don't need. Make this one here. Size of int. Let's make here a fast little bit space so that we can output a little bit better. And so this size of int will tell me which bits my current system supports here in this IDE. So when I run this one, again, you can see here, it says here 4. But what means this 4? Here we have here no 4. Careful, this is bits. And this size of operator, this keyword size of and int as an input returns us bytes, which means if I have 4 bytes, let's convert the 4 bytes in bits. How we make this? How we convert 4 byte in, let's make it directly, it's 32 bits, right? We know that 1 byte is 8 bit, or I hope you know it. Then you can say, okay, I have 4 bytes, so I have 4 multiplied by 8 is 32 bits. So I know I can only use 32 bits, and this number here is bigger than this number here, approximately 2 billions. And how I make this, I say, okay, I count here 1, 2, 3, 3 threes, and then 1. So let's see, I can count here 1, 2, 3, that's okay. 1, 2, 3, that's okay. 1, 2, 3, that's okay. 1, and all this other one I kick out. That should be working anyhow. I don't know, I have not checked this out, right? But okay, that is not good. Let's make one more time. So, and now you can see this number is printed out because it is in the range. So I can use this. So one more thing before I go on. What is if I want indeed this number here? How you make this one? So I want this big, oops. I want this number here. All right. So what I can do is I would go here to this 64-bit. I would need this kind. But how I change to this range here from, let's say from this one here. And we have here, if you don't know it here, you can watch this table here a little bit. And you can see here are the bits again. And here it says at least. So which means this 64 bits here on our bit size has really big, oops, here in this case in integer, has really big numbers, but still they are very big. Still I don't know if this is fitting in, but they will, I think. And you can try this one, and let's go in. And in my case, I would just go here to this range here, at least for a 64-bit, and then I would use one of this other spare modifiers here. Or let's say these are also types. So I would change it is still an int type. You can see it's still int, but it's just bigger. I made it bigger here. So this one will work on me. So I can use this one here, long int. Now I make long int, but I'm still not, no, I still don't know if this number is really working, because this is 64-bit and 64-bit is, where is that? This kind of long. I can use this kind of number. Let's copy this one so I can see it. And this one is for unsigned and this one is for signed. Let's copy this one here. Let's see if my number is bigger or not. Then I still can have problems here. Let's make this so. And oops, paste this one in. And you can see this will be, I don't know. Let's test it. I think if there comes a strange number out, it will not work. No. So let's see. It's not working. Let's make this one. Now I know. Now it gives me at least an error message. Before it gave me nothing. So you can see here we have problems with big numbers. And actually you can even go bigger numbers than this one. If you say, hey, I switch to the 128 bits. And then you can really go to really big numbers. And you can see here something like, I can't even tell this number. It is so big, really, I can't tell it. I mean, I can't spell it. And if you would even write these numbers, I think you would need several years just to write them down per hand. But the computer can make it, but a human can't make it. So big they are. It will take long. That's what I want to point out. So important is that you know this kind of stuff, because these numbers which you are using, and here let's say the other ones here are more important even. This one here, this character 8 and the 60-bit, they have a little range here, you see. So you can mess up here even faster than with these big numbers. Most time we are not using these big numbers. Most time, careful. Of course, if you make calculation high with big numbers, then you have to think about this. But in general, you saw in my tutorial, we use numbers around 1000, and so that was it, or something like that, or let's say till 1 million and so. But these little numbers here, you have to be a little bit more careful because they go easy out of range. All right, I think I talked again much about this one, but this one is still important for us. And yeah, let's go back. So here we have this one, and I showed you this one here. I just checked the list and I know it. But now the second question, the same thing like here, but here I ask for 12-bit. And if I jump now here to my list, oh, wait a minute. We have a specification of 8, 60, 32, and so I don't know the number of 12 bits. And you see that's a problem here, which means we can't use lists. Of course, you can go to the internet and try to find just what 12 bits is. And you should actually, because like I said, we don't memorize these numbers. And yeah, you go to the internet and find a way. And what you should know about this 12 bits is, for example, we can calculate actually these numbers here. And here on top, when we read here a little bit, they have here a formula how to calculate this kind of numbers, which means, let's take just this formula. So don't worry if you don't, if this formula is little and explain it very fast. It says here you take q and then in exponent you write the size in bits. For example, this n means here in size in bits. For example, in my question I asked for 12 bits. So you write this n is 12. So q 12 minus 1 is 11. So we have here this here means plus q in exponent 11, because I subtracted here one of my 12 bits, which is 11, and then I subtract minus 1. For example, you can make something like that, and if you do something like that, then you have it. Then you calculate this time, and what we can do is then here, actually I have here even a converter, not a calculator. That's even a step further. I want to show you this converter. In a moment I will show you this. But here, you can just use an online calculator. Let's do this. Online calculator. We go here. And here you have an online calculator. When you see something like a formula like that, what I showed you, where is that? Here in fundamental types. And here you just take this one. So we said 12 bits, okay, q exponent 11 minus 1. Let's write it in our online calculator. Q exponent, it was 12 minus 1, right, is 11. So that's why I write 11 and then minus 1. That's the formula. Is this right? Let's check this. Yes. Q 12 minus 1 is 11 minus 1. Perfect, perfect. And then I make this one and I have the answer. Careful. What is that here? Of course, when you read formulas like that, you should read the whole thing here. And it says this is the range for plus for unsigned, signed, right? So I calculated it for the signed version, which means it has negative and it has positive. So this one means my calculated values is the plus version, and now I have just add to the minus version, which is this one, and the minus version has just not this minus 1 here, which means you can just double this one here for the negative one. It's the same like here, you add just here plus 1 to it. So what means this? I copy this one and I write here as the second answer, use formal or online converter. And here I paste, okay, can I paste my, okay, the formal. The problem is I can't copy this formal here, I think. That, can I copy it? I don't think so. Let's copy it and try it. Yeah, it's doing something like that. Because that's not the format here. All right. Okay. That's not really working with copying formal. There is a library where you can copy even formals and so things. I have not set it up, that's why not working. And anyway, we can make it handway. And I show you in a moment even a better way than this formal, because this formal is still very complicated, right? But it works. If you know this one here, you can really calculate all numbers which you need. All right, that's very important. Let's make this one in a moment here. And what I said here, this is the plus version. Okay, plus, and now I need the negative version. Let's write the negative here in front, perhaps. Make here a comma and write it in front. The negative version is the same thing like here, plus 1, because the formal said that we need 1. Why is this 1 more? Because just the formal set here, but of course you can think about it here. It's the same like this one. Here we subtract 1. Here we have no subtract 1 here in the bottom here, which means I have just to add here 1. And that's my range for this one. And if I want to make the second range like here for signed, let's write here a little bit perhaps the format as well. This one is, what was it? That was signed version. Let's make the unsigned version. this one here. And how you make this, you just add this one to this one, and then you have this. Careful, when I say add, I mean not this one plus minus this one. That would be not the thing. I mean here just this part here, this positive without this minus. So which means we have here anything like 4095. So if you add this one without the signs, so this one is our value. But you see, we have here a problem. And what is the problem? We have to use a formal. It's cool when you know this one, but perhaps you don't know this one all time, right? And then you won't make it fast, very fast, because, you know, we want to concentrate to our program. We don't want waste here. Oh my God, this is 32 bits. How I convert it now from this one to this one? And the answer is you go online, or you have anything, and find online online converter. So which means you just say what you want. I want, for example, let's go to our example here. I need 12 bits. The problem is this online converter is give you options from, to, and here are the formats which you have. And I said we in general we are talking in decimal. Decimal is this numbers here, what we're talking. But in programming we have of course other formats as well. If you don't know these other formats, you have to read them a little bit on online documentation, a good C++ book, what they are, because this is there is much to talk about this. Impossible to do this in a practical video. So you read this a little bit. And important is you can skip at start octal and hexadecimal, but you should read decimal and binary at start. If you have never heard about this one, read at start binary and decimal converter. These two things here, that's very important. Just for understanding purposes important. And the other one becomes later important. But here, this binary, especially this binary, you should read. And decimal, is that what we use? Then you should know how to convert, for example, decimal to binary, because that's the thing what I'm doing here now. Decimal is our full numbers. Actually, that's not what I'm doing. The other way around, I will do it, because I'm asking for decimal. I want ask for a number. Decimal means I want know this number here, like here, but I have only bits. But the problem here is binary is not bits. Bits and binary are not the same thing. Bit is the is one element where you can save information which is normally 0 and 1. So I have a problem here. And this kind of stuff you should read also on the online documentation if you never heard about bits and bytes and something like that. This is theory. You should read about it. You should know a little bit about it. It's very important. But this is just for understanding purposes important. Later, for programming purposes, yes, you need sometimes solve problems which is related to this kind of bits and bytes. And all time in programming, you will see in this fundamental types later, they are talking also about bits and bytes. That's why you should have a basic understanding about this one. And let's go back to our question. The problem here is I have 12 bits and I need this number. I want to make it fast, right? And I don't want in this case the formal, because the formal is also fast, but I have to just get the formal, the calculator, and then type in the formal, and then I can get these numbers. That's cool. And how I get it with these bits now? Actually, if you know what a binary is, then you can transfer first the bits into the binary. Let's make this is our start point, because I have the bits. I know I can translate them to binary. Okay, I have it here. And what I want to know is not decimal in this case. I want this full number, what we use in general, because I write this in decimal. Decimal means here what we use in general in numbers. We are not using this hexa and octal. And now still the question is, okay, I have this one here and I should enter here now this binary. The problem is this is still bits. How I can find it? very easy. If you know that bits are just slots where you can put binary digits in, which means you can put in 0 and 1, and these are just 12 places. What means 12 places? 12 places means you can write here something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And these little places are that what you can, this are, let's say this represents now 12 bits. And the same now you can do with the zeros. Let's say I have not counted this one and I hope this works. This should be also 12, and you understand what I mean, right? So the point is this 12 bits is easy converted to binary. And when you ask then here min and max, that's easy. Because if you ask for a specific number, that's not easy, because then you need probably a calculation thing. But when you ask here just min and max, which means I can just write here 12 bits with 1, 1, 1, 1, 1, 1, which would be my max, and 0, 0, 0, 0, which would be my min. And let's do this. I start with 1. I need 12 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I press just convert. And you see what I have here. Here is my number. And important is this number is what you have also to know, the format here. It is the unsigned format, the positive format. And at least we have found out that this one is right. And the negative format here, I don't know. Can they make this? Perhaps you have to calculate this one. Okay, I think you should first learn this kind of stuff, and then you will see how to learn this converter. And here you can know all time, divide this by 2. I think this formula you should know still a little bit. I mean, then you can use this converter even easier, like this one here. Oops, not this one. Here, this one here, that this one is the plus, the halfway. The half is more or less our yes, unsigned version. Yes, I think that's it. And here one more thing what I wanted to show is what we have here. We have here a wiki how. Of course, you can find better places, but this one will work also. And here they show you how you convert, for example, binaries to numbers, how manually, not what I say manually, I mean with hand, how you convert this one in hand and all this kind of stuff. Read this in this online documentation, and then you see how you can calculate this with hand. And later, don't make it with hand, just use this calculator online converter. That's it, fast. Or use the formal if you like more formals, like numbers here, and then it's also fast. And I talk so much about it, I think we should go on. But this is very important. So the most important part on this question is that you should learn binaries, bits, bytes, and all this theoretical part behind, and how to convert these numbers. In our example here, that you have know that not all numbers work automatically, like I showed you here. You can cause problems, and then you have to figure out how to change here this length and so on. All right, that's very important for programming, and we go on. So the next question is here, 49. What is keyword long? What is that? And why they use the word bits to explain keyword long? And you can see here we have back our bits. Like I said, you should learn bits, bytes, and all this kind of stuff, because this CPP reference com here, they are using actually bits and formats and all this kind. What they are using, you should, let's say, have some base knowledge, not absolute in detail, but some base knowledge. So I hope you can know this. First of all, what is keyword long? I have talked about this in a moment, actually. I showed you actually this what exactly this is. When we jump here to my example, we have here something. But try to answer this one a little bit more in detail now. First of all, long is a modifier, but also a type. And this one is a little bit irritating. Many think when they read long, it is just a modifier. That's not true. Long is also a type. What I mean with type is, let's jump here to our list. I think we talked already about in the tutorial, we definitely talked about this here. It says here type specifier. Type. It is a type, and this list has long as well. And the irritating part is here on top, when we read here the modifiers, this one, signed, unsigned, short, and long, they are also modifiers. Here, signedness modifier, and here, size modifier. And that's irritating a little bit because they say it is now a modifier or a type. In this case, it is both. It can modify it. For example, when we use here int without long, it has the size of int, which means it is at least 60 in this case. And if you add a long to it, to an int, for example, it makes it have a higher size. So our answer is long is a modifier, but also a type, very important. And how you can test it that this is true. So how you can test it that it's not just a modifier? Very easy, actually. You jump to your example and you say here, if it's, so let's make here a little number. Let's get rid of this kind of stuff. And let's get rid of this one. If this would be here just a modifier, this one would not work, right? In this case. And if I start, this is working, which means no complaint. And here's one more trick, and I hope you know it. What was the trick? How to check if what type we have for this big number? We can just add here this, in Visual Studio, you can add here this debug node, start, and then this debug jumps here, and here in our list here, here's my big number. Here the value is not set because I'm still here in front, but here the type, it says long. So you can see it is indeed a type, not just a modifier. That's very important to know. All right, let's jump back to our question. And we have answered this one. And now the next thing is, the next thing is why they use the word bits to explain the keyword. So let's see. We have to go to the explanation of what they are using. So here it says long and target type will have width at least 32 bits. So why they are using these bits, and here in long target will have width at least 64 bits. That was the thing what I talked to you before. They are explaining this one to indicate that you must be sure that you can expect a certain range, which means if you are using, for example, int, you can expect 60 defined. But if you use long, you can expect at least 32. So this one is the minimum. It will not go for, if you use long, it will be not 60. So you can make your calculations or your preparations of size management from this point on. But it can be more. And here it's the same. For example, it says here int at least 60, but my system, what I showed you here in my example, when I jump here again in front, my int here, we have a size of int was 4 bit. So I have 32 bit. I have to calculate with 42 bit. And the reason, and that's why they say here at least, because they don't know what PC you are or what you are using. But they guarantee you it will be 16. And why is this important? Because there are even smaller versions as well. For example, I showed you here. Where's the other thing? No, down here we have also size bits in 8. For example, our character was this, can be small here. They guarantee you here the range here depends on what you are using. Again, 8, 60, 32, and so on. That's very important. And let's go here to back to our say. So why they are, let's go to our answer. Let's jump here back. And here we say why they use the keyword big to explain keyword long. And the answer is to indicate the size, what we can expect, something like that. Okay. So we know the size, which the minimum size. So we know the minimum size, what we can expect, but we still have to check. All right, like I said with my int example, you still check your system, but this is just an indicator information and so on. I think that's enough and we can go on. So we jump into the next question, which says, what is the keyword namespace? Make an example. Explain syntax in CPP, reference, com, and examples. Namespaces is big in these examples. We will go not in all detail because it's really big. And we have not talked about many, but of course you can, when we talk about these examples later, you can read a little bit more. I will not go through all examples. I will just go over some. But before we go over them, let's start from the front. First of all, what is the keyword namespace? Namespace, in short, it avoids it is used to avoid, let's say, so it is used to avoid name conflict. That's so the use case of this namespace. I wrote this one, that's okay, I think. Make an example. Let's make a fast example, which means we create fast namespace. You can use here the syntax if you want, so that you train the syntax as well. And I think we should train here the syntax perhaps. Yeah, let's jump in and use the namespace syntax. Let's see where I am. Have I a namespace here? No, I have not. Let's go here to the namespaces. I open this one up, and here we see we have here different kind of things. We are here namespace declaration at start. Let's open this one up. And here you can see what I said here. We have our syntax. We have here a lot of things. And at start, we are just concentrating on this one. And later we will talk about the other syntax very briefly. Of course, you can go over them. And this syntax, I copy this one. And let's see if I can use this one. Important is we check first this one here perhaps and this one here, because this one we have to find. Let's read this NS name, what it means. Here for the namespace NS name, so namespace definition, which means I should open this one up as well. And then I can see what this namespace name definition is. Actually, it's just an identifier. Normally it is just an identifier, so let's skip this. And say NS name is our identifier, and we have talked about identifier. Identifier is just a name, which you give, and then the compiler knows, okay, you have declared this name, so it knows when it search for this one. And declaration is also clear, I hope. Declaration means all things what you want put in a namespace. For example, variables, functions, later classes, structs, and enumerations, and some more. So all that, of course, I think that's okay. So we understand at least this one syntax. I copy this one. I jump here to my important is where I can use the namespace. I can't use it in functions. I have to be out of the functions. Here's my namespace syntax. Let's make it so and then use it here. So first of all, I need the name namespace. Let's write it fast. Let's do it. Namespace. Then I need the this NS name. I said it's just a namespace name. Identifier. Identifier is just a name. Let's call it my namespace space for demonstration. Because you should give all-time good names normally, and in this case it's just a demonstration, so not very important. So I have finished this part. Now this curly braces I need, okay, I have defined them. Here's my scope of my namespace. And now declarations, and then you can write here some declarations. I make my standard declaration and my telephone number. Phone number is this one here. Of course, you can declare not only variables here, you can also declare functions here, right? Let's make a fast, simple function declaration. Void my function declaration. And here, interesting is what we have. What is that? I don't know what's going on. We will see it in a moment. Let me see this, why it's complaining there. Not really complaining, it's just annoying here. Expected a semicolon. I don't know. why is that's not very important. Let's see why in a moment. So with that said, this is just an error bug, which is not really an error. Crazy. Anyway, we go on. So this one is right, and let's see what we do. Now it's gone anyhow. So, and you can see this green scribbles here, and this means it has not a definition. This one is just a declaration, and of course you can write the definition in this declarations as well, but we will see that we can write it even outside, and then you have a little bit think more. So I would rather write it here directly in it. So with the declaration and definition on the same time. So in this case, I keep this. So we have this, and I made this example. Let's go back to our question, which says, what is a namespace? Yes, I did it. Make an example? Yes, but I have not used the example. Let's make a use of this example. So I have just declared here a namespace, but never used it. So how I can use this? Let's go rid of this one. And I can say here, for example, I want print out, I show you something else. I copy this telephone number here, exactly this one. I place it here, I save it, and now I have two variables exactly the same. And we learned something that should not happen normally, right? But when I start now this program, you can see it works. And why it's working? Exactly while we have declared it a namespace, and we learned also this one will work with as scoped variables as well, which means if you have our own scope, it will work because this is not visible at this place. And yes, when we talked about scope, you know that this one can work, for example, with if yes, as long as it's local, it's not visible for the compiler, and it's possible. But we have still another problem. What is the other problem here? Let's get rid of this one too. The other problem here is which number, when I call, for example, my telephone number, I want print out my telephone number. I copy this one here, and then I paste it here. What was that? Was it not? I copied this one here, and I paste it here. So what is the problem here with this my telephone number here? I want just print it out here like this one. The problem is which one it will print it out, this one or this one here. Okay, it's highlighted, it's already, it knows this one is in this scope, so it goes here. But what is if I want to specify let's say this one here, how I get access to this namespace now? We learned this, right? What we are using all time? Yes, it was what was it? Yes, it was our resolution operator. And why this one? This resolution operator says, I will find for you what you have specified here, which means you start from right, my telephone number, the resolution operator says, I will search in, and then you have to specify on the left side where this resolution operator should watch. In this case, I want not that you watch here in this scope. I want that you go to this namespace here. Go to this place here and try to find this my telephone number in this scope of this namespace here. Okay, I put this namespace here in front. I may save this one, and now let's make here other numbers so that we can see they are not the same. And then we start this one, and you see now we have 44. This is this one and not this number here. So, and that's why this resolution operator is very, very important. You will see it in a moment why when we talk a little bit more about namespaces, and we will. So we go to the namespaces. So I made this example. Okay, I hope you made an example as well and repeated what namespaces are. So make not too complicated examples. We make simple examples. And now let's go to this part where we say, explain the syntax. We have to explain a little bit more about the other ones, and I will not explain all. We have not talked about all, and we will explain some of them. So let's go on. Here, the second, we have not talked about the inline word. It has different kind of different meanings. And in namespace, it has another meaning, which you can read where here a little bit. I skipped this part here. Yes, because you will see. Read this a little if you are interested. Read what inline means in this case. And then namespace, we have also not talked about this one much. This one has not a name, and this will shift also the scope. This kind of things are a little bit complicated because, and this also at start for starters, and it's very irritating even not for starters. You will see it in a moment what I mean. And then this one you should know. This one is just we call the identifier and a member function, which means that exactly this one is that what I this one is exactly what I did here in my example. Let's jump it here. Exactly this one. I called the namespace. This is the namespace name, and then I called one of my declarations. Right? Very simple. So this one we know, perfect. This one we know too. We have talked about this one, but I said we never use it. This using namespace name. And this is that what many beginners learn at start in many tutorials. And if you use this one, and the reason why they like this one is you skip all time this resolution operator. And I said in my tutorial, no, learn this resolution operator because it's so important. It makes your life easier later, and you will see in a moment why. This resolution operator, like here in this demonstration, I can exactly pinpoint out what I want. This resolution operator will exactly go where I want. I say go to this file here, to this namespace here, and get me this my telephone number in this namespace, which means this resolution operator helps you a lot to find exactly that what you want or what you want called. That's very important. And if you use this using namespace, let's use it. Let's copy this one here. Let's make this, paste it here. Instead, this namespace name, of course, I have to replace with my namespace name. Let's do this one here, copy. And I replace this one with this one here, paste. So now using namespace, and I use this one here. So, and now I get rid, normally when you make this one here, many starters say, okay, I use this namespace here and I can get rid of this resolution operator, right? Because that's why they make it most times. And you see no errors here, but when I start, it prints out this one here. What happens here now? But normally I have set using namespace, my namespace administrator here, this one. But it's printing out this one here. Why it's printing out this one here? And you see we have a problem already here. Because normal perhaps I wanted this one and you expected that this one is printing out this one, but now it's printing this one. Even so, you have used this one here. Because you thought, okay, now I'm using this one here, but it is not using this one here. And like I said, to avoid all these things, just use this resolution operator, and then you don't care if it's here on top or if it's here. You exactly pinpoint out what you want. You say, I want this namespace, this declaration, and give me that, and all other things I don't care. This one using is not good to use. So we are not using, at least I say all time, don't use it. And here we will make some more examples in this page where you will get really hard irritated, and then you will start to like probably this resolution operator more than you think. So here we have again using namespace, and here of course this one is the same thing like before. Instead of a whole namespace here, let's copy this one here as well so you can see this one. You can just using parts of this namespace, which means here, what is that? Okay, was just here. This one here. Actually, let's get rid of this one here. It was this one. Yeah, I have copied the wrong one. That's why I should copy this one here. All right. Anyway, we replaced this both two. So first of all, what you need here is this namespace name. That would be that one. Let's copy it so that you saw it one time. this one, and then this, you follow just this syntax here, colon, colon. Let's use colon, colon. And this time I say use this one explicitly, this one here. I want that you use this member, and it's called here member, like you can see, member name. Member means it is defined in this scope here. And that's why it's your member, and I paste this one in. And here, namespace, oops, of course, this one was the wrong copied one, sorry. Using, this one here is the right one. Using, yes. Of course, I should write using right, then it's working. So now I have the syntax of this one. Just copied the wrong one here. So with that said, let's test it. And what we have here is, I can get rid of this one perhaps. Let's cut this off, save this. What happens is I get an error which says here, what is the error? See declaration. Okay, here it says multiple declaration here. All right, it's not working. We skip this. Check this out, but normally you will get access to it. And here we have multiple declaration because we have it already here, and then you are bringing this using exactly here, and then it conflicts, something like that. All right, let's go on. That's not so important because I don't like using anyway. Perhaps you like it, and I will tell about this like and not like a little bit more here in detail when we talk about the examples. So let's go to the next syntax here. Namespace name qualified namespace. What is that? What is that? We can watch it if you don't know it like me. Then you go to 7 and then you watch it, and then you say see this one here. And yes, see namespace alias. Okay, they are finding new names for the namespace. We will see here examples later. And the reason why they find new namespace names, so they redefine the names of a namespace. For example, if you have this kind of stuff, redefining this one makes no sense. But what they have is, later you will see in a moment, is this qualified namespace name can be a nested namespace, which means you have here one namespace, here one namespace, new here one namespace. And instead of typing all this kind of stuff, you give them a new name and then use this one name. There will be an example. This one is important, but let's go on a little bit more. I think we have not talked about the nested namespaces so much anyway. That's a problem as well, but let's go on a little bit. So here we have namespace, NS name, member name, declaration. This is, let's see, 8. Here is an example. And here is this, I think we have not talked about nested namespaces, right? You can nest, of course, I have in my example here, namespace. Of course, I can define here another namespace. Like so, I say, okay, namespace, another, other namespace, other namespace in namespace, other namespace. Let's call it just other namespace. And here you can define again int my telephone number. Let's call this one here. I can define, use it again here, and it's not complaining. It's not nice. Now I have so many telephone numbers and it's not complaining because I can pinpoint. Okay, this one, I should not use this one. Yeah, here we will talk in a moment, but important is you can have here namespaces, and what they show here on line 7, this is very nice to learn, but this will not work on my PC. Careful, you have to read the green line again. So if it's not working on you, check on your PC, you check this one that you have activated. This one, for example, this one will not work on me. And what I mean not work, this one is working. So you see there was no complaint, but this one, this presentation here is probably not working because they say this one is equivalent to this one, and this one is the normal nested namespace representation, and this one is the shortcut. Let's see if the shortcut is working on my So how, for example, I want to go access this one here. I want exactly access this one here. How I get this one, like I said, here's the telephone number. I say search this one here. I say go in. You go in. It's in this one here actually. Here is it. Paste it. But this one here is a nested namespace, which means search this nested namespace in the member of the other namespace. So I need another resolution operator here. This one, oops. Let's make it so. Okay, and then you say search this one here and this one here in this member of here of this one. So search this name here in this member of this one. So how I make this, I just copy this name here. And I put it here in front. And you see this resolution operator helps me exactly to say exactly where it should show. And when you read it now from this line, go first here, then go here, and then give me this one exactly. And when I save this, start this, I don't know why it's worked, but it's working. I don't know, perhaps I have an update. Normally it should not work. It's working anyhow. Oh, wait a minute. This was a call. The call is working. That's normal. I made a mistake. I should make a representation. Let's see if I can make a representation. It's not working. This call is working because that must work, but the presentation must not work, which means if I, let's see, if I get rid of this line for a moment, and let's make it so. Copy this one here, and then I just convert this one here like they did here. Let's see if I can do something like that. And here, this one should work now too, but in my presentation will not work. Copy this one, paste here, and then I can, let's see, is this the presentation here? Yes, it should be fine. And here, let's make here fast and uncomment. Comment, I mean. And then here you see I have a problem now, which normally it should work on your system. And that's why I say all time check this strange little numbers here, these green lines. This one here will work if you have an supporting version. Let's copy this one here. Let's go here to the compiler. I have something like here. I use all time this compiler here. And let's delete all the other things what we have there. Let's paste this one in, and you see it's already not pointing out number. Here's the output, and the output says returned with 0, which means this one is valid in this case. It's working. Nice. And of course you can also go to this copy inside, and here when you run this one it will tell you what it's doing, and here is the output. Also it works. And here you can see this line here, and I talked about this inside a little bit. This one shows now exactly what it is doing. And you see this one, this line here was that what I did here on top, because this one is the equivalent alternative way. This one is the more compact way, and you can see this one is showing step by step. Okay, you define a namespace, then you define a nested namespace, and this is your definition. It is working. And that's why I showed you also this inside here. It's really nice. It gives you more information how something like that, for example, is really presented in another form, and can help very many people, for starters, and see a little bit more. In the last one I made an example that was too complicated with this. I think there was a template and yeah, casting and so on. That was too difficult to understand, but I think here it makes now sense. You can see this one is equivalent to this one, and they show all the steps. So go to this site here as well. It's really helpful. Compiler, of course, this one here you don't have to understand right now. In future, when you go to professional C++, then you will learn probably also a little bit about compiler to understand these steps, because this compiler here is let's say will exactly give you detail what the PC, or let's say the compiler, is doing in hardware representation, because all this kind of stuff what you see here in our code will be, let's say, here in the compiler code as well, transferred, and it's a little bit more accurate than what you see here in the C++. All right, let's go on. I talked again, and you see my is not working. That's why I delayed this one, but I can activate this one, uncomment. And the best thing is, what I should do is just update this and get Visual Studio. I think 2022 is for free again, is as long as you don't use it for commercial use. And we don't use it for commercial use, at least me not, because I just show you here some thing on YouTube. And this one shows again error, but this is not an error. It's some little bit buggy. Sometimes this presentation, it's working. All right. We can go on to our questions. I jump here, this marker. We go here where we are. So we have talked not about all examples. Too bad, we have to go back. And now let's see, we have talked about this one, and this one is even later. This one supports just this one, but let's skip this one. It's again inline. It's a little bit complicated. So let's jump to the examples. And actually, I made already here in my code some examples. So we will not talk of all examples, but this inline you have to read. It will cause many problems. So that's why you can read this on your own. And this one causes also many problems. And I will talk more about the problem and why we are not using this using word here in namespaces, why this one caused super problems. So let's go here. Namespace, and here is just the normal namespace declaration. Let's go here. Skip, you can inline skip. Yes, that we know. I use this one. Attribute optional, that was not shown here on top, and you see this attributes. You still have places where you can use this attributes. Important to note, identifier, like I said, it's the name, the namespace, and that was my example what I used. So the identifier was not here. All right, and here it's more or less the same. Let's watch a little bit this example and see if we can understand it. Not all parts, only some parts. So you can see namespace first Q is defined, nested namespace, and here is defined here. This class you can skip. And what we have here, this is a function, and interesting is here what I told you, sometimes you can declare a function. I showed you this also in the example what I made. You can declare a function. This is just a declaration, and that's very important. This is a definition. You need for every function a definition so it works, and this definition is outside of the namespace. That's interesting. We have never talked about this. I think we make there a special video because how to use kinds of stuff like that. But of course you can read. And here in this example is something very, what I have never talked, I think. First of all, this extern, we skip this. This is a special keyword. We will talk about this in future. That's not here. We have a function, which is a void function. But this one here, this little comment here, read this one. And here, when you read this one, irritating would be this first part here. What is this first part? I have not talked about this one so much. So, but I talked about this other parts, only not about the first part. But this one is a resolution operator. That's okay. But what is this? Why we have nothing in front of this resolution operator? Because I said all time, this resolution operator will try to find that what you have specified on the right side, which is, for example, in this case, H. It will try to find that on the left side. So I showed you this example with my example here. My telephone number jumped to other namespace. It's here, so my telephone number is in other namespace, and other namespace is in my namespace here, and it's perfectly defined, right? This kind of stuff. And this one goes the same too. This one, normally you read from left to right, but let me start here from right to left again. Here, H, where is this H? So normally you start from, let's read here from left to right in this case. The problem is, here we have not a start point, there is nothing. But we have a resolution operator which is asking for Q. which says I will find Q for you in nothing here in front. I will say what this nothing is in a moment, but let's figure out this other part here. So where is Q? Q is, you go here. This is my first namespace here. This is the namespace what I have, and this is my first namespace what is defined here, right? And then this namespace Q has a member V. What is this V? V is also a namespace which I have declared in my scope. Yes, and what is this H? H is, we have to go in V because I can't watch in Q now, because now I'm in V because I've specified it here. So I can't watch the other places now. I have to watch this one. This resolution operator specifies it. And H is, let's see, in V. Where is V? Oh, where is H? H is not even here. We have a problem because I have to go here, but H is not here. You see that? That's also, yes, the problem is we have not talked about this one here actually. H is here, but we have a declaration of F. F is defined outside, and that's why H is here actually, outside of V. But the problem is the resolution operator goes here, and then you have jump from here to the definition and find the definition here. The declaration is here. A little bit irritating. We skip this a little bit because I said this one we will talk a little bit later how to get and why so. But of course you can read this. But important is this one here, the start. What is that? And here, let's say here's Q. That's my namespace Q. There is nothing else. I can't see nothing else. Where is this nothing else? And that's exactly it. There is nothing, but careful. There is still one thing. And to show you this one, I have to copy all the namespace here. I have to go to my example. I go here and I have to specify, for example, this namespace here. I put it here and you see I copied here. And here after Q, what comes after Q? Exactly this one. What comes after this one? When you go out of Q, this resolution operator goes out of Q. Here's my scope. When you go out of Q, there is one more namespace, which is not called namespace, but it is called the global namespace, which means if you define something here, you probably know I defined it something like global name variables. And this global namespace is, yes, global, let's call it global namespace in our case. But there are, you can define the global namespace. You can define the function, the global functions, the global variables, and all things are here in global. And what means global? Global means it's accessible in the CPP file from everywhere. For example, I can access now this. Oops, where is that again? Here, main. I can now access, for example, if I define here anything here on global, I can access it on every scope. So for example, I can try to access it from this scope, and so on. So we talked a little bit about global, right? So global means just I can access it from everywhere normally. Careful, there are some exceptions too. And yes. With that said, this one is so important because you will see this sign later more, especially when you read this inline, and it will make, well, like I said, this inline and this unnamed operators will change the scope, and you need to understand that this one will shift to this one and this one will shift to this one. You will see it in a moment. Let's continue. I want to try just to explain you this one means global scope, and I hope you understand it now. If you see something like that, it's shifting to the global scope, and global scope means access from everywhere now, and can cause more problems from everywhere because now it's no more specified in a namespace. And that's the problem with this global scope. When you are putting a namespace in a global scope, because everybody has access, everybody can be conflicted with other definitions because it's in global scope. So let's continue a little bit with these examples. Let's see what we have here. And is here something important? Let's switch. Let's go fast over it. Here you can see we have again our nested. You can see here is a normal call without global namespace, because you go here in Q, you are searching in V, and you are calling function. And important is also what I have not talked that much, which is very important, this resolution operator, right? You can ask for functions, which you can see here, can be a function, right? Can be a namespace, like you can see here, but what we have not talked so far, it can be also a class. It can be also here a variable. It can also be a, I don't know, it can be many other things as well. So you have to check all time what it is looking for. That's very important too. So not that you think all time this is a namespace or this is a class. We don't know at this point. This one is most time this variable on front. It's also the first element is most time important, and the other ones can be class, namespaces, or other things as well. Or yeah, we'll see this. This is very important to keep in mind and train this a little bit later. Let's go on. So in this case, we have a class. What I say is class. Sorry, I mean we have here a function, and this function is in V, a nested. So what is doing here? And here we have an error. Let's see what's happening here. So here it says, okay, I call V, I go in V, I call F, and it says okay. Then I have here again V and G. In V, I don't find a G actually. Why it's saying that? Yeah, it's not member here. That's okay, because here you can see that there is no G. So that makes sense. I think it's not too difficult. And here we define a new namespace, which is namespace again, a second nested namespace here for G. We have now two nested namespaces, but here we declare G, and you can see it's just a declaration like this F. And we declare again namespace outside of Q, which means they are, let's say this one is in global, this one is also in global. And then not an enclosing namespace for Q. Let's see. I think this is standard. So this is just calling G. This is, but it says here an error. So figure out why this is an error. It's probably because it's just trying to get access where it can't get an access. It cannot define here. It says already. What's this? I think I should not go too much in detail. This kind of stuff you can read and try to figure out. And all the other examples, there are much more. I will not go now into detail. Will be anyway more complicated to explain when we go down. Will take much more time to explain. That's why I will skip. But I mentioned only some important parts now, all right? And all the other things you try to figure out, and only which we have talked so far. For example, here what we have here. Let's go here in. We have here again namespace class. You can skip at start. We have never talked about classes right now. And yes, what is this? Define AG. Okay, let's skip this because here is a class that will cause more problems because we have not. Here's this inline namespace, and this one you can try to understand, and this will cause many problems because yeah, you can try to read it, try to understand it, because it's shifting the scope a little bit. Try to read this one. I skip this again, and yeah, let's go here. What we have here they use again inline, and then you will see, okay, skip this class here, of course. Here and skip this template, of course. We have not talked about templates. The better is you skip the whole example here because we have not talked. And here this unnamed scope, unnamed makes not sense. We have talked about unnamed variables already, right, in functions, and I said if a function has unnamed variables, it's can be used for what was this unnamed variables again? As parameters. One reason is, for example, you just don't want to use it, but you need it for defining or declaring this function, something like that. In this case here, it's different because you can call an unnamed namespace, and you have to read this a little bit. And you can see now here something strange happening. Again, global scope, it defines the global scope is defining a unique name for this unnamed namespace, and you can call it. And yes, I think we will talk about this one a little bit in another video, a little bit more specific, because this will cause, again, let's say, problems, I think. But you can read a little bit about it, so you have already a little bit more knowledge. And the reason why I show you all this kind of things is this can happen. You should not be irritated and so on. But don't worry, at the end here, I will show you something very, very nice about all this and something very, very bad at the same time. So here, what we have here is, yeah, the syntax. I think we start to get to understand this one. Again, I can't run this example here. This was this using declaration. Okay, here the using declaration was on top, what I showed you here. And they show you now, what is that again? Yeah, here they talk about this global variables here. I said that's very important that you understand this one here is a global variable, global F. And then how to treat them, how they can conflict a little bit, and so on. This one is again something new, and this one will irritate also a little bit, even really hard, but actually not that hard. It's only strange. It looks a little bit strange, and this one looks also strange. So that's why I said here, when you see something using : F, means just this one is using the global namespace, global, it comes from the global namespace, and then F is defined in global namespace, and you can see here void F, this function here, this function declaration actually is no definition, is in global namespace defined, right? That is very important, is this one. If you understand that, that's cool as a starter. If you understand not the other things, no worry, step by step. And here, let's go here. These are just examples what we saw on top. And let's see what they have here. Is there anything important again? Yeah, they make here this using examples. You can try to understand them, and you can see which problems they make. And you can see they will, yeah, here is one more interesting part probably. This here. Yes. Why this, if you have here using RF, for example, it says here, it can call the one with int, it can call the one with char, and try to figure out why it's calling this one or why it's calling that one. The best thing is you read this one as well, but I just go here through that and see what is important to mention. Let's see here. What we have here is a little bit more. This one I have not talked, perhaps I should mention this one as well. Of course, you can have namespaces with here. What is that again here? Watch these two lines. What is that again? Or this one here. Okay, this one you can skip. This is struct. We have not talked. But important are these two lines. These are functions. These are function declarations. But important, look, this one here. FF. Why you can make this one here? What was the reason? Yes, these are function overloads. Overloads. Why you can use with function overloads with the same name? The important part is that you have different parameters, and you have here different parameters. Think about that too, that you can use function overloads in namespaces as well. And then you can see here they are calling a function. This is just a normal function call. And they have some errors here because they are using this one here, and then they have errors because, yeah, you have to check this out. I think these examples here you will understand the most of them, with which are without struct, of course. But all the other functions you will probably understand here and try to understand why there is an error, right? That's here the point, and I think that's okay. Let's see what we have to see here. Is here something important again? Here you can see we have here overloads. We have here now 3 overloads, and we have here again F Now they make here namespace B, namespace C, and you see these are all FFF functions, right? FFFF. They are all overloads, but careful. We have here a problem with this overloads. This one is a double, and this one is also a double. This one is a int, and this one is a int, which means as long as they are in separate namespaces, it's okay. But if you are using word, start to use this word using, and then this one, and then using this one, you have to careful what is called and if it's allowed. And then you see they make here an error, and then here also an error, and try to understand these errors here when you are trying to understand this one here. Because I don't go now through this one, takes too long. I talked already. I point this out, and here you can, and I think you can read this one on your own and try to figure this out. It's not too difficult, really not too difficult. And here, let's see what we have here. Let's see if we need this one too. Again, this using. So, and then you see they are using this one and this one. And here's an error. Try to understand this one. I think you can figure this one out as well. And here is a problem with using the directive. This one is a little bit even more complicated because here they talked about, not this one, here they talked about using declaration. And here they are talking about using directives. This one will make all things even more complicated. And the reason about this one is you should read this one a little bit and see what this is, because now the namespaces here, this nested namespaces, are shifting and they are violating some rules. Let's say not really violating. You don't expect that this is allowed. Let's say it this way. And then, oh my God, why is this now allowed? Why is this not allowed? And you can see here, for example, using namespace D, it says here names from D are injected into C. Okay, let's see. We have here C, right? And I use now make this D, and all this D is injected to C, which means now this one is now here. That's normal. That's not very strange. Names from A are injected into global namespace. Okay, that's this. Why that? So this one has here a namespace A. So we have here namespace D. It's using namespace A. Namespace A is here on top. And this one is now using this one here. And it says namespace from A are injected to global namespace, which means it's had an effect here on top. And this one is now global. You see, it becomes more and more complicated when you use now something like that. And really, that's why I wanted not explain all these examples. That was one reason, because that takes hours. And you should try to make this on your own. You will probably understand not much. Don't worry. If you are a starter, don't worry. I don't understand all them too. Not really, because I don't spend enough time. You need to really spending a little bit time for it. But I have a good news and a bad news at the end, like I said. So don't worry about that. Let's continue a little bit and see what we have. And here they making again this using namespace, and you can see here they are introducing to this space. This other is to global space. Yeah. And then try to read this one as well, and there are some other rules, and then try, this is the last example I think, and then try to understand here some of this kind of thing here. So we are at the end, and at the end I said we skipped, I think, this example. Here's one more example. Let me see. This is a template example. Let's skip this. And this is our vector. Let's skip this as well. Okay, we can skip the last example. It's too complicated. But the other ones here, you should try, let's say, understand. So what is the good news and what is the bad news? I said after we are finished with this one, here's a good news and a bad news. The good news is, before I say that, let's repeat this one here. This one will irritate you really hard, because this shifting of this declared variables on global, in other, and all this kind of stuff you have to consider. So what is the good news when you hear something complicated like this one? The good news is You can avoid all this by not using the using keyword. You can just avoid it. You can just say, I use the scope resolution operator, what I showed you in my example here. Just forget about using and never use it. And that's why I said at start, we learn in this tutorial learning this resolution operator, because if your code have never used this using namespace here, or what this is, you have just defined the namespaces here, then you just can point out with the resolution operator exactly where you want to go, and it is defined. This using here, for example, it is shifting the scope of this declaration. For example, here, using 8, so all names from A, which is here, which is this int here, injected into global. Okay, this one will anyhow transfer this one to global now, into global namespace. And when you go here down, then you have this D and so on. So you can forget this all. Just use this resolution operator and never use using in your code. And it's very easy. So you can have here millions of namespaces here. If you use, let's copy this one here. Copy and rename this here 2 and make this here 2. So, and now I say I want exactly this one here. Then I can just say, okay, I go to namespace this one, copy this one, let's make it this one here. Well, let's copy, yeah, see it out. I go here, resolution operator, okay. And then you say, okay, I want this one here, right? Then I say, okay, here I go to this, here I go to this, and copy and paste, and then I say I want exactly this. All right, you want exactly this. Okay, cool. Here's the resolution operator. All right, I have it. Okay, it becomes very long. That's the problem. But here I have exactly that what I want without using. That's why I said you can avoid all this headache to understand and yeah, this shifting here. And the problem is in future, let's say you have used this one and you are adding new things, let's say from an update, or you change your code or you rework, then you have reconsider all this kind of stuff, which means you have to know that this was injected in the global namespace, for example, and this was now used there, and now you updated a project which will say this one is also in the global namespace and make a name conflict, and that's bad luck, your program is broken, something like that. So it can cause many problems, but if you use this name resolution operators, not. And here's another problem, but you see this one becomes very long, and but we have a solution for that. If you paid attention, what can we do here? There was something nice on top. One of these declarations here is interesting, and it was, which was it? This, we have not talked about this one here. This one here, this definition, when you read it, you can redefine, which means you can give another name for namespaces. For example, let me copy this one here, copy this one here down, and paste this one here. And now I make this one here. Let's use it and see if I can do this one here. Okay, namespace, shortcut namespace 9. Let's call it shorten namespace, shorten namespace. And then I have to use this equal sign, and then I has qualified namespace. Here, this is my qualified namespace. Actually, I can use this one here. Yeah, this one here. Let's make this one here. Just this one here. And then I say this one here, I want to use this one. And then I can go here, and then I can call this one here. So what I can do now is, let's copy this one here. let's place this one here. Let's comment, for example, this one fast out. And let's use the short namespace here. And I can put it here in front. Here is the variable what I want. And here's my short name what I want. And you see you can make even very, very, very long spaces very short. You have the information what you want. I want this one. And then you have this shorten. And important is here one more thing. If you say, okay, but I don't see now where I get it. Here, when you hover your mouse over this one, or you go here watch a little bit more in detail, you will find this. But here, when you hover your mouse over it, it will give you here, yes, it will show you what it is using here in detail. Right, so all these little steps what I did here on top. And it is just shorter. You see it is possible and without the word using. And if I'm not using the word using, all the headache what I can get there with shifting of this one, I can avoid. That sounds very promising. That sounds very nice. But I said I have a bad news for you as well. Not only positive news. This one was the positive news. What is the bad news? Can you think about it? What is bad? The bad news is if you write the code and not using the word using in your project, then you have no problem. The problem is, what is if you are using other codes where they have used the word using, right? For example, you're working with other teams, they have used the word using. That means you can't avoid to learn all this kind of stuff what they show here. That's the bad news. You can't avoid it because other people might use it. You have to understand it. You have to figure it out, which means even if you are not using it yourself, you have to understand all this complicated stuff too. That's the bad news. So on your own project, you say, I don't use it, I don't care. But other people might use it and you have really to know all things here. And that's really the point, which is really annoying. Yeah, you can't skip it with other words. That's the result. You just can't skip it. Like I said, at start I said you can avoid it when you use the word using, but you can only avoid it for your own project. That means not that you can avoid it in general, because other people will use it, and you as a programmer, you have to understand all codes. Yes, that's the bad news. With other words, we can't skip it. We have to learn it. And we will learn this step by step. So that was just more or less in this video an overview. And there's much to talk, but most important is you just understand the first one here. Perhaps you understand this one here, how we get, and this resolution operator. And you understand that this using is really bad. I hope you understand now why using is so bad. Because if you make these examples here with using declaration, using directive, and how they shift this scope, and they will cause many problems. And here this inline, you have to read this one as well later. We will make this in the tutorial, in the future tutorial, a little bit examples for all of them, so you can get more used to it. At start, important is just this one here, that you know this one here, that you know that using is very bad. And yeah, that you know we still have to learn all other kinds as well, because other people know will use it. And I think I will stop here at this point, because now I talked very much again and I did not very much here. All right, here's one more thing perhaps that we can make before I quit. And this is the last one, because this is also namespace here, and it's very short. So this one is very short. That's why we make this one fast before I quit, which is, it says here, what means namespace aliases? So, and this is exactly that what we have. I show you this one here directly here. So I talk too much. Where is this aliases namespaces? See, I showed you the list here, right? That we have here different things here: namespace declaration, namespace alias definition, and using directive. This using directive here, that's a little bit the complicated part, which shifts all. And here, let's go to aliases, and we have talked about aliases as well. And you can see here in example exactly that what I did. You have this one here, you just shorten, right? Exactly, that was my last example, by the way, so I don't have to talk much about it. Exactly that one is name aliasing. We say we don't use using, but we will get very long names and we can shorten them up. And we can make just find a short namespace name, right? You can just make it very short. Bang, and that's very good. So that is aliasing, and I think this example here is very is similar to mine. They declare here a namespace, a nested namespace, and a nested namespace. And here they declare the actual useful variable, but calling all this one here, like so, they say we make a new namespace which combines all of them, like so, and then we just call this one. And exactly that I did here. What a coincidence, right? And yeah, that is name aliasing. We have not talked about the syntax, but I think that's now very easy. Name. Here is the new name, and here are all the names which you want combined and make a new name about it. So the syntax is also very simple, and that's it. I think that's why I wanted to go for this one as well. That was very short because the most part we have talked here. So what means name aliasing? Shorten the name, just shorten the name of nested namespaces. Namespaces. All right, you understand what I mean with nested namespaces here. That's exactly that what they do. We shorten the name, so we just can call this one, and that's it. And yeah, that was again a very long video, but very important part, and probably you have to do a lot of work on your own this time, because I talked about things which we have not really talked about it, and you must read this kind of stuff online, for example, on top with this bits, bytes, and so on, and how to convert it. Binary is very important, this bits and bytes, just basic understanding. Don't worry, we don't need much about it in programming. We need it only because this bits and bytes, because this documentation is using all-time bits and bytes. You see with this the explanations. And yeah, I think we have not talked much now. I have talked much, but we have not made many questions. But I hope you still followed most time. You know most of them. If not, no worry. That's why we make it. We try and train it. We repeat it. We extend it. And with that said, if you have any question, any complaints, any tips and tricks, write it in the comments. And see you in the next video. Bye, good luck, and like all time, don't give up. You get better and better with time. In future, you are definitely better than me.